Today we're diving into the quantum realm with one of the most famous thought experiments in history, Schrödinger's cat, quantum mechanics. It's a term that sounds complex and intimidating, right? But don't worry, we're going to break it down and make it as friendly as a cuddly cat. Speaking of cats, imagine a cat. Now imagine that cat in a box. In this box we also have a vial of poison and a tiny bit of radioactive substance. The setup is such that if a single atom of the substance decays, it triggers a mechanism that breaks the vial, releasing the poison and, well, it's not a good day to be the cat. Here's where quantum mechanics comes in. According to its principles, until we check the box, the atom is both decayed and not decayed at the same time. This means our furry friend is both alive and dead simultaneously. This is called quantum superposition. But here's the kicker. The moment we open the box to check on our cat, reality chooses one state. The cat is either alive or dead, not both. This is what we call collapsing the wave function. This thought experiment raises mind-bending questions about the nature of reality and the role of observation. It's at the heart of many interpretations of quantum mechanics and has implications for everything from the multiverse theory to the nature of consciousness. And that, dear viewers, is the paradox of Schrödinger's cat. A tale of a cat that's both alive and dead, a tale of quantum superposition, and the strange world of the very small. If you enjoyed this video, give it a thumbs up and share it with your friends. Stay curious, stay excited, and as always, keep exploring the universe in our next video. Until then, goodbye and keep the science alive.